Hello students. Today we will learn about linear momentum and the second law of motion from class 9th chapter force and laws of motion. Dear students, we have already discussed about force and its effects, and in the next video class we have discussed about the laws of motion. And first law of motion we have discussed there. We have discussed the type of inertia and basically what the inertia is and how can we measure the inertia. Today it's a very important topic, that is the linear momentum and a second law of motion. Do you know, students? Let's start this video class with an example, a day to life example. For example, if I throw a cricket ball towards you with certain speed, you are in a position to catch that cricket ball. But if I fire a bullet towards you, can we catch that bullet? No. What is the difference between two? What is the difference between the cricket ball and a bullet? You know, the bullet is bullet is fired with a high speed. Otherwise, the mass of that bullet is very small as compared to the cricket ball. But you cannot catch it. So similarly, if we change the scenario, if we change this question, if we change the idea, if we take a football, a big ball, and a cricket ball, it is very difficult to catch a cricket ball that hurts our hands, but a football never. But the mass, if we compare, the mass of the cricket ball is more as compared to the football at that time. So these concepts, these examples provides us a very important concept that the motion, a quantity of a motion of a body depends upon either mass of the body or the velocity of the body. You see, when a bullet is thrown towards you, when a bullet is fired, it has high velocity. It has high velocity. High velocity. This high velocity gave an idea. This high velocity becomes the factor that the body has the quantity of motion more. For example, this bullet has quantity of motion. That quantity of motion we call as momentum. That quantity of motion we call as momentum. And the momentum of that bullet is decided by the high velocity. Or rather simply we can say velocity. But if we take a stone which is rolled down from a hill, and on the same time a football is rolled down from a hill, and I am asking you to stop one of them, you are easily to stop the football, not a stone which is very big in mass, and you are not in a position to stop that stone when it is rolling from certain hill. So because that stone has high mass, and the quantity of motion when it rolled down has high. So here in the second example, you see that the momentum of that body or the quantity of that stone has described by the mass of the body. A mass of the body. So we can say that the quantity of motion of a body is known as linear momentum, and the linear momentum is described. Linear momentum is, there are two important factors which decides the momentum of a body. One is the velocity of a body, and second is the mass of the body. And this is what we can define linear momentum as, the product of mass and velocity. So let us start now with the literal meaning of momentum. So literal meaning of momentum is the quantity of motion possessed by an object the quantity of motion possessed by an object is known as momentum. Now, what are the factors which decides the quantity of motion? It means that how can we say that a body has a larger momentum? Yep, that body has a greater quantity of motion. And that depends upon, dear students, that it depends upon the velocity of that body or the mass of that body. So this is why there are the two important factors which decides the momentum of a body, or this quantity of motion. This quantity of motion that we call as momentum. It is decided by either the velocity of that body or the mass of that body, or the mass and velocity of that body. So we can say the quantity of motion or the momentum of a body can also be defined as, it is also defined as the product of mass and velocity. The product of mass and velocity of a body is called momentum. So momentum is the product of mass and velocity. If we represent this statement mathematically, we can say the momentum P is equal to the product of mass. Let the mass of the body is small m, and the velocity of the body with which it is moving, that is v. So we can say mass into velocity. So the momentum of a body is equal to the product of mass and velocity. So for the units of this momentum is concerned, or linear momentum is concerned, we can use this relation that P is equal to mv, and substitute the units of mass and velocity in this relation, and we can find out the momentum, units of the momentum. For example, we know the mass has measured in terms of kilograms in case of SI unit system, and in case of velocity it is measured in meter per second. So substitute these values, we can find out that momentum is equal to kilogram and a kg into meter per second. So kg meter per second is the SI unit of linear momentum. So dear students, I recapitulate once again the linear momentum. Linear momentum of a body is the quantity of motion possessed by an object, that is called linear momentum. This is applicable only when a body is moving on a straight path. This is why it is called a linear momentum. Or simply you can call it as a momentum. So the quantity of motion possessed by a body is called a momentum. It means that what is the amount of motion possessed, what is the ability of a body to move or possess a motion, that quantity we call as momentum. And that quantity, that how much body can move, what is the total motion of the body, what is the amount or quantity of a motion of a body, that is decided by the two important factors. That is, one, it is decided by the velocity of the body, and second, it is decided by the mass of that body. And I have given examples. For example, when a bullet is fired from a gun, that bullet has high momentum, and that their momentum, the bullet's momentum is decided there by means of the velocity, because that bullet is fired with a high speed. So here the bullet has high momentum because that bullet is moving with a high velocity. So velocity is the one of the factor that decides the momentum of the body. And second, I have given you an example that if a rock is rolled down from a hill, and we are not in a position to stop that rock, because that rock has high momentum at that time. Why? Because that rock has a tremendous mass, and that tremendous mass decides the momentum of that body. So again, the second important factor that decides the quantity of motion, that is the mass of the body. So this is why we define the product. It is the product of mass and velocity of the body. So the momentum is the product of mass and velocity of the body. To find out the units, we can use that the mass is measured in terms of kgs and velocity is measured in terms of meter per second. And we can say the momentum has SI unit kg meter per second. Now, what is the relation between this momentum and second law of motion? You know, Newton, a great scientist, have given us an idea that whenever we apply force on a body, we know whenever we apply a force on a body, obviously, for example, we take an example again. For example, if a body having mass, the body having mass m, this is the body, it has mass m, and this body is at rest. The body is at rest. The body is at rest. So its velocity will be 0. So its momentum will be equal to mass into 0. That will be equal to 0. So when a body is at rest, its momentum is 0. When we apply force, what happens to the momentum? The body, when we apply force, it means that this body moves. The velocity of the body will change. The body will change its velocity, or the acceleration is produced in the body. And obviously, initially, when the velocity was 0, its momentum was 0. And when we apply force, its momentum gets changed from 0 to onwards. So that indicates when we apply force, what is the change in momentum in the body? There is a change in the momentum of this body, and that rate of change of momentum of the body is directly proportional to the force applied on the body. This is the basic idea of the second law of motion. So according to Newton, Newton says when you apply force on a body, and that force will change the momentum of that body. What is the total rate of change of momentum? How much momentum, at what rate the momentum is changing? That is basically rate of change of momentum. So rate of change of momentum of a body will change, and that rate of change of momentum is directly proportional to the force which is applied on the body. So if you know the magnitude of force which is applied on the body, that force is directly proportional to at what rate the momentum of a body is changing. So we can say F is directly proportional to the rate of change of momentum. Let us see how can we find out the rate of change of momentum. How can we find out the relation for second law of motion? First, we will decide its relation. So let us discuss the second law of motion, Newton's second law of motion. Dear students, for that we take an example to understand the second law of motion. For example, we take a body. This is a body having mass m. A body having mass m. Let this body has an initial velocity u. The body is moving, and it is moving with an initial velocity u, or rather we can say the initial velocity may be 0. It may be at rest also. So the initial velocity is, maybe it is a 0, or it is moving with certain velocity. So a body having mass m moving with a velocity u, initial velocity u, if we apply a force in the direction of its motion, the force F is applied on this body, the body will move faster, because the force has a capability that it can increase or decrease. It can increase or rather decrease the speed of a body. So you have already discussed, you have already learned those things in the effects of force. So when we apply force on this body, the body having mass m, it is moving with an initial velocity u, or rather we can say that the body has initial velocity u and that is equal to 0. that is the body is at rest. So in both the cases, when we apply force, there is change in the velocity. Because when a force is applied, if it is at rest, the body comes into motion. Its state of rest will change into state of motion. Okay. Or rather, if the body is moving already, then force is applied in the direction of its motion, then the body will move faster because the force is applied in the direction of its motion. So the force is applied. When a force is applied, the body has changed its initial. After moving, the body has mass m, and by applying force, its velocity will change from u to v. This change will take place in time t seconds. So we will write down this description, the example, and I will write down the description. I will write here, let a body of mass m is moving with a velocity, with an initial velocity u, a force is applied on it. A force is applied on it that will change its velocity. That will change its velocity from u to v. So, if we find out now, take this example in order to explain the second law of motion. We have a body having mass m, and this body is moving with an initial velocity u, and I am applying force in the direction of its motion. So the body moves faster, its velocity will change, and its velocity will change from u to v. And this whole thing happens in time t seconds. And the time for change, its velocity is t seconds. So change in velocity. Time taken to change in velocity, that is t seconds. Now, it is important here to understand. Let us take an example you have already discussed. You have already discussed that the momentum of a body is the product of mass and velocity. If we check here the mass and the velocity, in the first case, when a force, before applying force, what is the momentum of the body? The momentum of the body, the initial momentum, the initial momentum, that is P1. P1 is equal to the initial momentum. Initial momentum here means that when a force is not applied, before applying force. So before applying force, what is the mass of the body? That is m. And what is the velocity with which it is moving? That is u. So I can write here mass into velocity. Let us equation first. Example, and find out the initial momentum of this body. You know, the body is initial momentum means when force is not applied on the body. Okay? When force is not applied on the body, the mass of the body is m and its initial velocity is u. So we can say initial momentum, or before force is applied, the momentum of the body is equal to the mass into velocity. Here the mass is m and the initial velocity is u. So the initial momentum of body is mu. Let us equation first. And now take the example. Take this example again and find out the final momentum of the body. That is the momentum after applying force. You know, when a force is applied, its mass remains same, but the velocity is changing. Velocity will change. If the velocity changes, it means that the momentum is also changing. So the final momentum P2 is equal to the mass is m and the velocity changes from u to v. So we can say its momentum is mv. This is the final momentum. To find out the rate change in momentum, if I ask a question to you that tell me what is the change in the momentum of a body. You can easily say, sir, it is simple that the final momentum minus initial momentum. For example, if a student is 150 centimeter in class 9th, when it reaches to the class 10th, and its height measurement will be taken, and let that is 160 centimeter. So I will ask a question to that boy, what is the change in height from 1 year? In 1 year, what is your change? What is the change in height? He easily minus the 160 minus 150, and that gets 10 centimeter. He can easily say that, sir, the change in my height is 10 centimeter. So whenever we find out the change, we always take the final height minus initial height. Similarly, when we find out the change in the momentum here, then we can subtract the final initial momentum into final momentum. Yeah, rather we say that the change in momentum is equal to P2 minus P1. The change in momentum in the body is equal to the final momentum minus initial momentum. And you know what is the final momentum? Final momentum is mv. The final momentum is mv minus mu. So this is the change in momentum. P2 minus P1 is equal to mv minus m2. This change takes place in time t seconds. So if we represent this change in time, then it becomes the rate of change of momentum. The rate of change of momentum. The rate of change of momentum of this body is equal to what? P2 minus P1 divided by T. The P2 minus P1 is mv minus mu divided by T. This is the rate of change of momentum of this body. And here now we can decide, we can describe, or rather we can say explain. We can take the statement of second law of motion. Newton says in his second law of motion that this rate of change of momentum of a body is directly proportional to this force. So if at what rate the momentum of a body is changing, that is decided by this force. If the force is greater, there is the greater rate at which the momentum of a body is changing. So force is directly proportional to the rate of change of momentum. So we can say if force is increased, the rate of change of momentum also increases. If the force is decreased, the rate of change of momentum also decreases. So rate of change of momentum is directly proportional to the force applied on a body. So the Newton's second law says, the statement of Newton's second law is, according to Newton's second law of motion, according to Newton's second law of motion, the rate of change of momentum of a body, the rate of change of momentum of a body is directly proportional to the force applied on a body. So if we represent this mathematically, here, this is the statement which I underline. This is very important to understand Newton's second law. The rate of change of momentum of a body is directly proportional to the force applied on the body. If we represent, you have seen in the previous example, that the force is applied F. So F is directly proportional. F is directly proportional to mv minus mu divided by t. This is the rate of change of momentum. So if I rearrange this equation, I can write it like this. F is directly proportional, m is common, then m is removed, then it becomes v minus u divided by t. So, from the equation first, equation of motion, that v is equal to u plus at. So, a here is equal to v minus u divided by t. So the rate of change of velocity of a body is called acceleration. So I can write F is directly proportional to m into a. Here v minus u divided by t is equal to a. So to remove the proportionality, we use constant, and here the constant is k, and it is equal to 1. So then F will be equal to k ma. Here I can write where k is equal to 1, then F will be equal to ma. So this is the statement, and this is the relation for second law of motion. So again I will repeat it, that the rate of change of momentum of a body is directly proportional to the force applied on a body. You have find out how can we decide the rate of change of momentum of a body, and later on this mv minus mu divided by t is the rate of change of momentum, and the force which is applied, that is F. So F is directly proportional to the rate of change of momentum. So F is directly proportional to remove m, because m is common here. So when we remove m is equal m into v minus u divided by t. To find out the v minus u divided by t, from a first equation, v minus u divided by t is equal to acceleration, because v minus u divided by t is the rate of change of velocity, and the rate of change of velocity of a body is called acceleration. So we can write, instead of v minus u divided by t, we can write a. So if we remove the proportionality, we use constant, and here the constant is k, and F is equal to kma, where k is equal to 1, then F is equal to ma. To find out the units of force here, it is very easy, that F is equal to mass, that is kg, acceleration meter per second square. So the units of force is Newton, and it is equal to kg meter per second square. So this is all about the Newton's second law of motion. So you got an idea that the Newton says that whenever we apply force on a body, there will be change in the momentum, and what rate the momentum is changing, that decides the force. And this is why force is directly proportional to the rate of change of momentum, and this is the relation. If we find out the relation between first law and second law, here it is very important. The first law and second law, there is a relation. The full explanation of this law, first law, is given by the second law. The first law is explained completely by second law. You know, we say that the force is equal to mass into acceleration. And in first law, the Newton says that when a body is at rest, it remains at rest. When a body is in motion, it continues its uniform motion till some force is not applied on the body. So in order to find out the relation between first law and second law, we know, if we see clearly, the first law completely explains the first law's explanation was given by the second law of motion. And we can say that the second law of motion provides an explanation for the first law of motion. Newton's first law of motion can be deduced from the second law. And Newton's first law can be deduced from the second law. We know according to Newton's second law of motion, the force is equal to mass into acceleration. That is equal to mv minus mu divided by t. Clear? So this is clear here. If the force is 0, let F is equal to 0, then what will happen? If F is equal to 0, if we not apply the force on a body, then obviously mv, if F is equal to 0, then mv minus mu is equal to 0. What is the time? Take the time, anything here. So 0 is equal to mv minus mu is equal to, that means v is equal to u. So when v is equal to u, when initial velocity of the body to its final velocity, it is obvious then when a body is moving either with a uniform motion, its velocity doesn't change, that means its velocity, initial velocity is equal to its final velocity, or another case is there when body is at rest. When body is at rest, that means its initial velocity is 0, its final velocity is also 0. So at that time initial velocity can be equal to final velocity, or when a body is moving with a uniform speed, its initial velocity will be equal to final velocity. When this thing is possible, only when no force is applied on the body. And this is the basic idea of the first law of motion, that whenever the force is not, a body which is at rest will remain at rest. A body which is in uniform motion, moving with a uniform motion, will continue its uniform motion till some external force is not applied on the body. And when the external force is applied on a body, means that the body either from rest comes into motion, or from uniform motion it can change its uniform motion. The velocity will change. But when no force is applied on the body, when force is equal to 0, then obvious thing that the body, its initial velocity will be its final velocity, means that the body is either at rest or it is moving with the uniform speed. That is basically the first law. And that first law explanation, we can say the second law of Newton's second law clearly explains the first law of motion. I will repeat again. First law says that if a body is at rest or of uniform motion, it will continue to state of rest or uniform motion till some external force is not applied on it. If we doesn't apply the force on a body which is at rest or a body which is moving in the uniform motion, they never change their state of rest or uniform motion. And if we see second law, we say in second law F is equal to ma, that is equal to mv minus mu divided by t. Here we can find out that ft is equal to mv minus mu. If f is equal to 0, if the f tends to 0, then 0 is equal to mv minus mu. So v is equal to u. Only in case v is equal to u if a body is at rest or if a body is moving with a uniform motion. So it is clear that until and unless you doesn't apply the force on a body, the body is at rest, or a body which is moving with a uniform speed will continue its uniform speed. This was about the second law, linear momentum of a body. Thank you very much, students. We will see you in the next video class. Thank you very much.